ये रिकॉर्डिंग मैं कर सकती हूँ?
कोई बात नहीं, मैंने तो वो कर दिया है, तो अभी आपको मैं ट्रांसफर करूंगा तो वो रिकॉर्डिंग चलती रहेगी।
अच्छा, कल की मीटिंग के रिकॉर्डिंग मेरे पास नहीं आए हैं।
हाँ, एक काम करें मैम, आप अब मेरे को अपना ईमेल आईडी दे दीजिएगा तो मैं आपको भेज दूंगा।
अच्छा ठीक है, मेरा smriti@ignore.ac.in है।
SMRITI@ignore.ac.
स्मृति ओनली, SMRITI है स्मृति।
ठीक है मैम, मैं कर दूँ। मैम एक साथ मैं ये दोनों कर दूंगा फिर।
जी
ओके मैम,
ओके, थैंक यू।
थैंक यू मैम।
हाँ हाँ ठीक है, चलेगा। वैसे मैं इकट्ठे। ओके, थैंक यू मिथुन जी, आई विल चेक। Who's this? Hi Tanima, today I am not having electricity here.
It's okay, it's okay.
So
No.
I am in.
So you have reached home or you're still in the office?
Negative. I'm at home. I reached
Okay.
home.
Okay, then that's okay. So we'll start by 6:30, 6:35.
Right.
है ना?
6:35.
Right.
Because it's habit now. Nobody comes on.
Right, okay, no issues. We'll do it.
I'm there.
Mm-hmm.
And internet is also not here. I'm using my hotspot of phone.
Yesterday also I was doing the same thing for the better half of the thing. Today let's hope my thing works.
And it's already on recording.
That
recording started already.
Okay.
But my laptop is having enough battery, so I don't think there will be much problem.
Okay.
Otherwise, I'll shift to
Dr. Gargav, may I start? It's 6:35.
Yes, Tanima, you can start.
All right. Fine. Thank you. Good evening, everybody. We are starting off our class today, and we just yesterday just a brief recoup of what we did yesterday. We spoke about data. We spoke about the collection of data, the classification of data. Uh, I did not touch much upon the graphical presentation of the data because I believe that is something that softwares do very well for us. And we then moved to descriptive statistics. In descriptive statistics, we saw that there are various measures of descriptive statistics, basically mean, median, mode, and of course, geometric mean, harmonic mean. Within the median family, we also have quartiles, deciles, and percentiles, which we can calculate. It's the same as a median is. And we were trying to do something about median when there was a power cut and I couldn't continue with my class yesterday. So I'll start from where I stopped yesterday. I stopped here. This was the numerical that we were doing. People who were there in the class with me yesterday, they know that. And if you have joined today, I suppose you can always see yesterday's recordings and become abreast about what is happening. So I suppose that IGNU will be sharing with you later on. You can come to know of that. So this is basically, we were just trying to do a median in a different, like if your data is presented in a different manner. Okay, before I move, any doubts from yesterday's lecture? Anybody who was there yesterday who couldn't get something? Is there any doubt? Anybody has any questions? कोई चीज़ जो ना समझ में आई हो आप लोग को कल और आज आप समझना चाह रहे हैं उस चीज़ को दोबारा से तो हम देख सकते हैं otherwise I'll start from here. All right. Fine. If you people have any issues, you can always unmute yourself and let me know where you are facing the problem. So this is where we are talking about that. Okay, Ganesh, thank you. We are talking about if the temperature data we have taken, and this is the range of the temperature that we have, and this is the frequency, and then we calculated the cumulative frequency, and then you can just go with this formula. So we yesterday in the first step we found out the median class, and for that let me just shift it here. So we found out the median class where we said that this is how you do it. M is equal to n by 2. N is your total of frequency. The total of frequency was 41, so which came out to be 20.5. And we then checked this 20.5 in the cumulative frequency, and we know that it's a part of 27. So 20 to 30 became our median class. So your median class is, if I want to write my median class, so that's 20 to 30. Now I apply this formula. So according to this, I'll apply this one. So M is equal to L1 is 20 plus N by 2 is 20.5 minus, now cumulative frequency, when you're taking the cumulative frequency, please remember that the cumulative frequency you have to take of the class before the or preceding the median class. So the class preceding the median class is 10 to 20. So we'll have to take the CF of this, which is 15. So we write it here minus 15 frequency of the median class, which comes out to be 12. I is class interval. I is your class interval. And how do you calculate your class interval? That is L2 minus L1. So we take this as into 10. And so you just solve this, and this comes out to be 5.5 upon 12 into 10. And then you can tell me how much it comes out to be. 20 plus 55 by 12. And 12 was a 48. So it'll be 4 point something. The answer for it'll be what, 20 plus 4 point something will come. You people can tell me. And so your answer will be 24 point something. So that is how you calculate it. So this is median basically that you have calculated. Are these calculations fine? Like, are you with me on these calculations? Is it okay?
Okay, ma'am. It is
Right.
clear.
Okay. Now my question. When to use mean and median? When do we use mean and when do we use median? Yesterday we saw mean, we saw median today. So when to use which one? Look, mean. Yeah, go ahead. Somebody's answering. Go ahead. Somebody has put on their mic. If you're not answering, please put off your mic if you're not answering, because otherwise it creates disturbance. Okay. Mean is one of the most, this is a very common measure. The reason that it is a common measure is that you are using, it's just an average. So we require average. Wherever you require average, you'll be using mean. Another very important use of mean is that when we you use it for so we use mean a lot for further statistical estimations. Like today, we'll be talking about dispersion. We'll be talking later on. We have got correlation, regression. So all there we use mean. So mean is a very, very, like wherever you want an average, you use that. Median, on the other hand, somebody has answered here. In case of a single extreme quantity, Ganesh. How just give me an example, single extreme quantity. Are you talking about outliers? Are you talking about outliers? Somebody can tell me what outliers are? Yes, go ahead. Yeah, we are listening. Okay. What are outliers basically? Outliers are, yeah, outliers he was talking about. What are outliers? Outliers are basically these are extreme values. So like, for example, let me take per capita income as an example. We all know what per capita income is. We know that per capita income is your total income or national income of the country divided by the total population of the country. Now, when we use this word total population, the income of Ambani, Adani, Tata, they are all there. It's all a part of. Madhura, I'm coming to that. I'm coming to what you are saying. So just give me a second. Let me just clarify this and then I'll just come to that. Now, a total population combines of Ambani, Adani, Tata. It also has the auto wala, the daily wage worker. Now, if we take if we are taking the national income, it is having on one extreme, like if I have this scale, so on one extreme I have people whose per day income might be in crores, and then on one extreme we have got whose per day income is in hundreds, right? But national income, so these are the outliers. These are the extremes that you have. Now what I suppose Ganesh wanted to say was that mean has like this is an issue with mean, that it includes all the observations. It includes all the observations. So when it is including all the observations, so it is including the outliers as well. Now, how do you correct that? How do you correct that? Generally, what we say is that one way is that you calculate your average with outliers, and then you calculate your average without outliers. And then you see the difference. You look at the difference between the average. And then you say that which better represents your data, which better represents your data. So you do that and there. So mean is very, very common. Now, what with median is that the difference between mean and median is that median is doing only, what median does is just divides the data. It just divides the data into two equal parts. So what we say is that this is a more of a situational measure. So it is just telling you. So even if there are outliers, even if you have got outliers in your data, median does not get affected by it. Median does not get affected because it does not look at the absolute value. Absolute value is not considered. The position of the value is what matters, that where is your value positioned. Because yesterday, if you remember, we said that you arrange your data chronologically, either in the increasing order or in the decreasing order. So wherever you want to say, you want to tell an address that, you know, this is like, you can take per capita income. One thing is that you take your per capita income and you say that, okay, look, you talk about India and you talk about, say, Spain, and you compare the purchasing power parity, PPP, and on the basis of PPP, you say that whether India is ahead or Spain is ahead. You're taking the per capita income. Or you can talk about, if you want to show disparity, you want to show disparity in the country, then you talk about the median income. Then you talk about the median income, that, okay, look, this is the income below which there is one population and below which the other population lies. So that gives you a very big things. So median, quartile, decile, percentile, these are not very good measures of central tendency. Like another example, because you people are from MBA, you will understand one more example, like the median size of shirts. So that tells you that, okay, what is the median size of shirts? So that might come out to be, say, 40. So we know that, okay, in India, you have got half the population of people who are wearing shirts above 40 and the other half below 40. So 40 is your median thing. So, okay, so you then get to know that, okay, this must be the structure of people in India, because we know 40, which size wears 40. So that is how it works. I suppose, am I making some sense? Am I making it clear? Is it okay? Is the clarification fine? Just give me a yes or a no in the chat box. Okay, right. Thank you. Fine. And now, very quickly, let's talk about mode. And okay, before okay, let me add. Very, very quickly, let me tell you what mode is. Mode is basically, if we are talking about mode, we represent mode by Z, right? So mode is the highest frequency. So if you are again, let's continue with the shirts example. Shirt sizes. So you have Which is the mode here? Which will be the mode here? Right, absolutely right. All of you are absolutely right. 40. The reason is that 40 is occurring 5 times. Okay, this is 5, this is 3, this is 2, this is 1, this is 1. So 40 has got the highest frequency. So that is mode. Okay, so that is how you calculate mode. Of course, in different series, the formula is change of mode, but that is what basically you're trying to find out in a mode. You have got the grouping table and the analytical table for if in grouped data, like if you're finding out mode in the grouped data, then there is this method called grouping table and analytical table. So you can use that and look at it. So now we move to dispersion. Now, dispersion basically, this is just a quote by Michael J. Montaigne, who said that there never was in the world two opinions alike, no more than two hairs or two grains. The most universal quality is diversity. So we talk about dispersion. So okay, let me see if I've added a few. Let me just tell you, you can read this later on. What is dispersion? Dispersion is basically looking at the data, finding out a central value, and then seeing that how far your actual observations, how far or how close are your actual observations from that measure of central tendency. I'm repeating myself. We calculate a measure of central tendency. We'll be calculating, like you say that somebody's saying something. Go ahead. We say that mean marks is 25. That's the mean marks of the class. So that means that there are, on average, the students have scored 25 marks. Now, dispersion will help to let me know that the marks of the students in the class, say supposedly the number of students is 100. So the marks of these 100 students, how close are they 25 or how far off they are from 25? Why are we finding out this? Why do you require? I find calculated the average marks. Why do I want to calculate dispersion? Yes. Why do I need to calculate dispersion? Somebody has answered. For average, no, Shruti. Average you have already calculated. I'm telling you the average marks is 25. Yes. थोड़ा सा दिमाग लगाओ, ज़्यादा नहीं. I know it's the end of the day. You people are all tired. Ganesh, you have got this fixation with outliers. No. No, outliers you can just find out, just you plot your graph, or you just look at, like you plot your data, or you just look at your data and you find out, like you take your data on the Excel sheet and you just do min max and then you give. Yes, Deepti. Okay, so why do I want to find out? Why do I want to find out the scatter? Absolutely right. All of you who are, okay, somebody gave Vidya says to achieve a target of how far are we from the target. Thoda sa, let me just refine a bit. As a teacher, I have got that very bad habit of doing that. I want to know how good is my average. Okay, so basically I want to find out that how good is my average? That means that is it truly representing my data or not? So I want to find out that is it a true representation of my data or not? So for doing that, for finding out the dispersion, there are various measures. Like if you just look at this graph here, you'll find that where is the dispersion more? In the first diagram or in the second diagram? Where is the dispersion more? In the above, upper one or the lower one? First one. Akshay says the first one. Okay, so please do not use the pen. Somebody, please. If you want to write, then I don't. There's no need of me to be there in the classroom. If you are writing, I don't. There's no need for me to write. Please don't do that. और यदि लिखना है तो फिर इधर ही आके लिखिए. Then I won't be writing it. All right. The first one, okay. That is what Akshay says, that it's the first one that has it. So of course we are saying he's absolutely right that the first one has more dispersion, because if you look at it here, you'll find that what? If you look at here, look at the spread. Your spread is much more. Like if I draw it here,
Madam, it was by mistake, so sorry.
No, it's okay, it's okay. But yeah, wait, it's okay. As a teacher, वो आदत है ना reflex में बोलने की, हमारी आदत होती है. चलिए, like look here. Here, if you find, you'll find them more close. मतलब if I'm drawing it here, one is this spread, and the other is this spread. So this is more close, like this is more close, this is more spread. So the dispersion is more here, right? So you've got different measures of things doing it. We'll be talking about two measures of dispersion here, right? So these are the ones you can have a look here, that you have got algebraic or absolute and relative. So you've got range and its coefficient, you've got interquartile range and its deviations, then you have got mean and standard deviation, and of course you've got the Lorentz curve. Lorentz curve, Gini coefficient. Have you people heard about Gini coefficient, Lorentz curve? Padha hai kahin pe? Have you people heard? Like in economics, it's a very common thing. We estimate the Gini, and then we find out the Lorentz, like we calculate the Lorentz curve. Excel does it beautifully for us. I recently used it for one of my papers. One of my scholars is using it for estimating inequality. Okay, ठीक है. If you have not heard Gini, Gini, Gini coefficient, we use that a lot for inequality, and there we have the Lorentz curve. So the distance of the Lorentz curve, or the width of the Lorentz curve, tells us that how unequal the things are. So we won't go into the Lorentz curve here. We'll stick. I'll be talking to you about these two, about mean deviation and standard deviation, because these are two. Range, range is very quickly, if I want to tell you about range, what range tells you is, it tells you the difference between the maximum and minimum. Okay, so you take the max value and you take the min value. So if you're using MS Excel, you write the function equal to max, and it will give you the maximum number of the range, and then you write equal to min, and it will give you the minimum number. So this is your this is basically what your range is, and then you calculate acha ek cheez, let me tell you this very quickly, very important. Why are we calculating coefficients everywhere? We are using this word coefficients. Can somebody very quickly tell me what coefficient, what does this word actually mean? Coefficient शब्द क्यों use करते हैं? Why do we use this? Sorry. Yes, somebody very quickly. Okay. A yes or a no? The question is there, are potatoes and students' marks comparable? Or let's take potato production, potato production and multiple of a number. What is a multiple of a number? Coefficient? Okay.
No.
No. Dilip Kumar says no. Absolutely no. Potatoes and students are not comparable. Now, when I want to make the, what I do is I make my data scale free. I make my data scale free. If I'm making the data scale free, that means there's no scale to the data. There's no unit of measurement to the data. Then what happens is that then it becomes comparable. So when we estimate the coefficient, as she said, as Vidya said, that it's a multiple. Okay, you can say that it's a multiple, especially like if you are talking about a regression. Yes, it's a multiple for your regressant or the estimator. What coefficient does is that it makes your data comparable. So if I have found out I have the mean production of potatoes and I have mean marks of students, and I have calculated the range for both of them. I calculate the range. If I then calculate the coefficient of range, then that will, not only coefficient of range, any coefficient for that matter, standard deviation, mean deviation, quartile deviation. So if I'm calculating the coefficient of the range, then I can compare both the things. Nobody can stop me there. And nobody will say that it's wrong, right? So it makes scientifically or mathematically, it makes perfect sense to compare the two, right? Am I clear? Like, is it clear? Do I make sense?
Yes, ma'am, it is clear.
Okay, thank you. ये देखिए ये max min 7 minus 1 so of no use, range is of no use. Quartile deviation is like this is how you calculate your coefficient, the maximum value minus the minimum value upon the maximum plus minimum. So that is how you calculate your coefficients. Then you've got the quartile deviation. Again, not, as I said, not very important. Now here, this is mean deviation, which is very, very important. This is very important. Now in mean deviation, what you are doing is that you are estimating your deviation. You are estimating, we are calculating the mean deviation. And this mean deviation that we are calculating it from, not necessary that you will be calculating it from mean, though the name says it's a mean deviation, but you can calculate it from mean, you can calculate it from median as well. Okay, so it is a mean deviation from mean deviation from a median. You can calculate it from both. Secondly, just give me a second, just excuse me for a second. Right. Okay, so you can estimate your mean deviation from either mean, median, both you can estimate. Generally, we say that it's better to calculate it from mean. Like that's easier to do, nothing else, nothing there. What we are doing is if you look at this formula here, one is you're using mod. These two signs, I suppose you people are aware of. If you're not from mathematical background and if you do not remember it, just recall that this sign, it stands for modulus. In short, we call it mod, and it means that avoid the signs. Basically, it says that you do not look at the signs. Yeah, yeah, modulus, we call them modulus, yes, and it's like, it says that you avoid the signs or you overlook the signs. That means a positive or a negative doesn't matter. 1. So now here what we are doing is you are finding out the difference between your observation, individual observation, and the mean of the observation, and then you are summing it up. I'm repeating. 1, this is mu, this is called mu, and this is called x bar. Both of them represent mean, but if we are talking about population mean, then we use the sign mu. If we are talking about the sample, then we use the sign x bar, right? If you are getting confused, just remember that you have to find the difference between the observation and the average. Okay, between the observation and the average, that is what you're doing. When you have found out this difference, then you sum this difference, which is basically the sigma sign is telling you, the big sigma sign. This means summation, and you then find out the average of the sum. So mean deviation is again it's the mean of the deviations, right? Mean deviation is the mean of the deviations. The only thing that you have to keep in mind here very, very specifically is that when you're finding out the difference, when you're finding out the deviation between your actual observation and the mean, the signs have to be overlooked because you're using modulus. Is it clear? Is it clear? Okay, Akshay says yes. Akshay, what have you done for your graduation? You've got a sound understanding of statistics. Engineering, oh, bachcho ka khel hai. Okay. Mathematics, like because you understand the basic mathematics. Okay, right. So let us, and this is how you calculate the coefficient. This is how you calculate the coefficient, right? You calculate the coefficient you calculate mean deviation and you divide it by the mean. So if you're doing that, then then you get your coefficient, right? So this is how you calculate this, and if you are multiplying it by 100, then you'll get it in percentage. Not necessary that you calculate it in percentage form. You can, you may not. Now this is an example. If we can here now. Sir, if you would just remove these signs, if you can, otherwise, okay, all right, because this is creating. Now, here we are saying that the number of patients seen in the emergency ward of a hospital for a sample of 5 days in the last month are 153, 47, 51, 156, 153. So these are the number of patients that they are seeing. So you first calculate the mean. So how do you calculate the mean? You just sum up, you find the sum of this, which comes out to be what? 7, 10, 11, 16, 19, 15, 16, 20, 25, 759. Am I right? Is this the total that you are getting? Is this the total that you are getting? 7, 10, 11.
No, ma'am.
No, 20, sorry, 20. ये 2 हो गया, ये 760? 760 is the total? 760, yes. 760 is the total. Okay, let me just rub it and put it here. 760, right. 760. So then you divide, your mean will be 760 divided by number of observations, that is 5. So you get what? 152, which is written here, 152. This is your mean. Now you find out the difference between each of the observations and your mean. So this is 153 minus 152. Now you are putting a modulus sign. So that means you won't be looking at this minus sign. You won't take it. So you have taken absolute deviation. You overlook this signs and then you find the total of it. The total comes out to be 12, right? You then find out you then find out the mean of the sum of deviations. So this comes out to be 12. 12 divided by 5, which comes out to be 2.5, 2.4, or approximately 3, because patients cannot be in decimals. Obviously, people can't be in decimals. So that your mean deviation comes out to be 3. Now, if I want to find out the coefficient, what I'll do is yeah, somebody wants to say something? Mean deviation upon mean. So this will be 2.4 divided by 152, which comes out to be how much? Please let me know how much is it coming? 2.4 divided by 152. How much is this coming out to be? .4 divided by 152. Your calculators are there with you?
0.01578, something like that.
0.017. Okay, बस बहुत है. 0.0157, right. So this is the coefficient that you have got, which will make it comparable, and this is the deviation. Now, please interpret for me. I've got a question for you that this is the question. Should the mean deviation be large or small? Should it be large or should it be small?
Large.
It should be small. Very good, Akshay and Dilip. The smaller it is, it'll always be better, because I'll give you the answer to this. If we say that it is 3, that means if your mean deviation is coming out to be 3, that means that you are trying to you're trying to your 152 is your mean. Your on an average, every observation is doing it with just a second, just a second. My father is here and he is a very old man and he can't like just give me a second, let me he doesn't know that I'm taking a class. Okay, let me keep this. Let me. Sorry for that. I suppose it happens with everybody. All right. Where was I? Okay, here, this is what I was talking to you about. Just a second. Right. So I was saying that mean is 152. So on an average, your every observation is deviating from mean, that is 152 by 3. If this deviation was, say, for example, instead of 3, this was 8. So that would mean that each observation was deviating by 8. So Monica, what is better, to deviate by 3 or deviate by 8? I suppose Monica answer, who gave that answer that large, it should be large? Who said that? Is it clear?
Okay, ma'am, it is clear.
ठीक है ना, समझ में आया? मोनिका क्लियर है, मतलब उसके पीछे का फंडा समझ में आया ना बेटा?
Yes, ma'am.
Okay, right. Okay. Now, my second question. I've got a lot of questions. My second question to you people is that should we overlook the science? Should we overlook the science? Like, is it mathematically, Akshay, you have done your engineering, you have done a lot of mathematics. Is it okay to overlook that? Is it fine, or we shouldn't be doing that? You have given an answer. No. Vidya says no. Ganesh says yes, you can. Ganesh, we can overlook the science. Science do not matter. Then why to look at the science? Like, why not always? Shruti says no, an emphatic no. Whatever limited mathematics I've studied, I know, I do understand that the science have got very, like they play a very important role. Of course, it depends on the objective. Absolutely right, Akshay, because mathematically, if a modulus has been used, that means it has got some use. Otherwise, it wouldn't have been used there. It depends on the objective. Most of the time, especially if you're talking in terms of statistics, if you're wanting to calculate something, especially if you're wanting to calculate sum total of deviations will be 0, Ganesh, you know, there was this gentleman who was very smart, and he gave you an answer to this question of yours, what you're writing. What you're writing, absolutely right. Absolutely right. You are writing that sum total of deviations will be 0 if we if we do not overlook the signs. Now, let me begin an example. That's the best way of learning, I suppose. The mean income of people is 50,000 per month. That this is the mean income, right? We say that income, like, I don't know why I wrote mean income here. Okay, mean income deviates. Mean income. What happened to it? Mean income deviates by plus minus 1,000. If I write plus minus 1,000, or if I just write 1,000, which will give me a better picture? Plus minus 1,000 or just simply 1,000, which will give me a better picture?
Plus minus.
Plus minus, absolutely, plus minus, because then I know that there are people who might be getting 49,000 and there might be people who are getting 51,000. So the plus minus gives me a much better answer than just 1,000. Now, what standard deviation we had, and we had this gentleman to thank for this. He gave he spoke about standard deviation, and to answer Ganesh's question, what he did was he said that you do one thing. You find out the deviation. That means you find out your x minus x bar. Do not take modulus. Now, if you just sum it up simply, it will come to 0. So he said that you take x minus x bar and then you square the deviation. You square the deviation. Now, if you now take the sum, of x minus x bar square, this will be overstating. It will be overstating the real thing, obviously, because if you've squared something up, you have increased the volume, right? So you do not want that. You do not want it to be overstated. So he then said that you take the under root of it. You take the under root of this summation. And what does that do? It will bring it back to the scale where it was. And then he said that you find the mean of this. You find out the mean of this, and this gives you standard deviation. This is what standard deviation is. ठीक है? कुछ समझ में आया? We'll do a numerical for you to better understand this. But did you get what we are trying to do? There we just stopped here. We just took the modulus of this and we stopped in mean deviation. Here what he said you go ahead, you take the square of it, and then you take the sum of it. You divide it by n, like find the average and put it under root, so that you can you have a better understanding. Is it okay? Is it okay?
Yeah, madam, it is okay, ma'am. It is clear.
It is clear. Okay. The teacher keeps asking, no? Yes, have you understood? Otherwise, we feel that you have not understood. These are the various formulas in the various data types, like if it's a grouped data, if it's an ungrouped data, then how you use it. Okay, so let us take this example. Let me move my photograph from here to here. All right, so they say that the wholesale prices of a commodity for 7 consecutive days in a month is as follows. So the prices are given, that is per quintal price has been given for 7 days. Now they have asked you to calculate the variance and the standard deviation. We'll come to variance as well. Variance is nothing but the square of the standard deviation. So it's just before you put the under root sign, whatever is left with you, that inflated number that we were talking about, that is basically your variance. That plays a very, very crucial role in statistics and in estimating things. It plays a very major role. So what we did, we just find out the mean. So this is summation x. Summation x came out to be 1820. We found out the mean, which came out to be 260. So this is the mean that you got. Then you found out the deviation. This is basically dx, your deviation, x minus x bar. So you said 240 minus 260, that is minus 20, 260 minus 260 is 0, so on and so forth. Now here we have taken these negative signs. So we have taken that. What we then do is we square it up. We squared it. So that comes out to be 400, 0, 100, 225, 25, 676, 16, right? We then sum it up. So this is basically your summation of x minus x bar square. Okay, the whole square. So we've taken this. Now, if you just divide this by your, like if you just get the average, the mean of this deviation, which comes out to be 206, this is your variance, which is basically square of standard deviation. If you then take the under root of 206, which comes out to be 14.352, this is your standard deviation. This is your standard deviation. So the interpretation is that larger the standard deviation, more is the dispersion. Okay, so it's like standard deviation needs to be small. It needs to be small. So smaller it is, the better it is. Fine. Now, Why is it standard? How much is the time? Why is it standard? Very quickly. Anybody? Why is it called standard? Ganesh, I suppose you got the answer to your question, to the statement that you made, that sum total of deviations will be 0. So you got an answer to that. Right. And why is it standard? Why is it standard? The teacher will answer. Okay, somebody answered. Ganesh, why are you so obsessed with outliers and each observation? Ganesh, what have you done for your graduation?
BCom.
Ah, so BCom, you just remember outliers, Ganesh?
Not like that.
Okay, let me just. I'm just pulling your leg, huh? By the way, don't, if you feel bad, then I'm sorry for that.
Okay, okay. Please answer. Why is it standard?
I'm answering that. I'm answering your question.
Okay.
We need to keep moving our board here and there. Why is it standard? The reason that it is standard is that if you have got a normal distribution, my writing is so good, drawing especially, fantastic. Okay. So if you have got a normally distributed thing where you say that your mean is equal to median is equal to mode. Now these are known as tails. These are known as tails. Like this is one tail and this is the other tail. Okay, so this is the tail. Your how many observations are within the body? How many observations are within the body? So what's if you are using standard deviation, we say that sorry, we say that mean plus minus 1 standard deviation, mean plus minus 2 standard deviation, and mean plus minus 3 standard deviation. So one standard deviation covers around about 66% of the data, 66 to 68% of the data. 2 standard deviation covers 95% of the data, and 3 standard deviation covers 99% of the data. So if you add, whatever your mean is, like in our case, what was the mean we had? I suppose that was 260. 260 was our mean. So if to 260 we are adding or subtracting 14.352, it will cover 66% of the data. If I say 260 plus minus 214.352, then it will cover 95% of my data, and 260 plus 3 times 14.352, it covers 99% of my data, of my observations. So almost all my observations are covered when I use standard deviation, and that is the reason that it is called standard, which no other deviation does. And that's the reason that standard deviation plays a very, 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 very important role in descriptive statistics. whenever we want to describe the data, we use this concept of standard deviation. Is it clear? Is this clear? Is this thing clear? Okay, right. Akshay says yes. I'll take that a yes for everybody. So with that, we come to the end of our this dispersion thing, and keep stop sharing. We'll now move to another topic today. So that is sampling. Okay, once again, please. Okay. Right. Let me share my screen again. And where is it? Where has my? Oh, here it comes. My screen is visible. My screen is visible.
Yes, ma'am.
Okay. Thank you. You have got 10,000 observations. You have calculated the mean. You have calculated the standard deviation. What would you like? Would you like to have an overview of all these 10,000 observations, or would you like to have an overview of only few observations? Would you like to have an overview of all the observations when you're describing the data? Do you want to have an overview of all the observations? That means all the 10,000 observations, or would you few? Okay, Shruti, why few? Why few? I'm waiting for your answer, Shruti. Why few? Yeah, please answer quickly because we have time consuming for all the data. All the observations, of course. Both of you are giving wrong answers. Solanki as well as Shruti. You people are giving wrong answers because we would. Why did we take all the observations? Why did we take all the observations? Why did we then take the data of 10,000 people? Please remember, the larger your sample size, the larger your data set, the better will be your results. The smaller the data set you will take, the worse your results are going to be. So if you are a manager and if you have just sampled 10 people and you come and tell your manager that 10 लोगों ने कहा कि product बदलना चाहिए इसलिए product बदल दो, तो they will show you the door. They'll say कि आप बदल लो, आप बदल जाओ. You go and tell them that I spoke to 1,000 people and they are saying that these things are to be changed in the product, and they'll appreciate you. If somebody goes and goes with a data of 2,000 people, that person will be appreciated much more. So the larger the data set you have, the better it is. So all the observations need to be covered. Now, where did I keep my pen? Okay. This does is okay, no problem. When you are calculating standard deviation, what standard deviation does is that it covers maximum observation. It covers maximum observation. So as I said that if you have mean plus minus 1 standard deviation, it's 66 or 68. Just let me have a look. Otherwise, there's no point of me giving you wrong information. I suppose, okay, it's questions and thank you. All right. It gives you 68%, if I'm not mistaken. Just have a look at this. I'm just putting a star. Just have it, is it 66% or 68%? Here I've written 66%, so I'm just putting a star over here as well. So it covers these much of your observations. If it is mean plus minus 2 standard deviation, then this covers 95% of your observation. If it is mean plus minus 3 standard deviation, it covers 99% of the data, right? So if you are doing this, if you are taking your, with your mean, if you're taking a plus minus 3 standard deviation, that means almost all your observations are part of your study. All the observations have been, they have been calculated. The standard, it is like if, the reason I drew this diagram was that if I am taking just 1 standard deviation, it is covering this much of it. If I am taking 2 standard deviation, then it is covering this much. This is 2 standard deviation. This is 1 standard deviation. And if I take 3 standard deviation, then I'm covering almost this much of my data. This is 3 standard deviation. So I'm covering almost all my data is being covered, which means that this is fantastic. Like if I'm having all this data in my study, that's fantastic work that I'm doing, right? So that's the reason that it is called standard deviation. Did I give you a bit of more clarity in this? Did you people get a bit more clarity on this?
Ma'am, I have a question. I mean,
Yes.
maybe
Yeah.
I'm confused more.
Uh-huh.
Earlier you told deviation should be less, then it is good. But in this case, why we are taking 3? We are considering 3 is better than 1.
We are saying that if your whatever value of standard deviation, we are not saying that it should be large. We are saying that whatever value of standard deviation you've got, you multiply it by 3 times, you add and subtract it from your mean. So that is the number of observations your standard deviation is covering up. उतने ज्यादा डेटा की वो बात बता रहा है वो आपको.
Okay, got it, ma'am. It is not clear. Yeah, thank you, ma'am.
Right. Anybody else has got any questions regarding this? Otherwise, I'll move to the next topic. Anybody has got any other? I can move to the next topic. It means for any data, we must have this. Yes. जब हम लोग अपना रिसर्च पेपर लिखते हैं और या फिर हम कभी प्रेजेंटेशन देते हैं, like if we are going to a company and we are presenting something, or we like do consultancy work, or we write our research papers, what we do is we make a table of our descriptive statistics. In descriptive statistics, we write the mean, we write the minimum and the maximum values, and then we write the standard deviation. So that gives you and variance. So that gives you a total perspective about your data. So from there we can, a lot of things comes out of it. कि बहुत सारी चीजें जो है ना वो आप उस data set के बारे में बता सकते हैं just by looking at the descriptive table, right? Concluding as the bigger the coverage range, it gives a better result. Right, Vidya, thank you for summing it up. Right. Okay, so let me just stop sharing my screen. And okay, we have this. Let me just save it here. And let me just move to the next topic. Here is my Zoom. And let us just talk a bit about sampling. Okay, let us talk a bit about sampling questionnaires and time series. You people have got sampling and time series and everything. Right. My screen is visible, I suppose. I'll take that as a yes, because nobody's saying that they can't see the screen. Right. So what is sampling basically? Sampling, as this figure very, very rightly is is showing you that sampling is that you're just taking some part of your population, and on the basis of that some part you are trying to generalize. Okay, आपके जो पूरा पॉपुलेशन है, क्योंकि पूरे पॉपुलेशन की स्टडी करना, जिसको हम सेंसस स्टडी कहते हैं, census study is very time consuming, it's very expensive. So have you people heard about PC Mahalnobis? Prashanto Chandra Mahalnobis, have you people heard about him? PC Mahalnobis. No? Hi. Please read about PC Mahalnobis. Please read about PC Mahalnobis. Prashanta Chandra Mahalnobis was one of the greatest statisticians of all time, an Indian, somebody who helped in the entire planning process. And this entire sampling that you people are studying today, or we are studying, and we do our entire research and sampling, is something that he was the one who initiated it. पूरे दुनिया को इन्होंने सिखाया है. We have got an Indian Statistical Institute in Calcutta, which was an institute that was started by Mahalnobis, and later on it was nationalized by Nehruji. And in Indian Statistical Institute in Calcutta, there were so many Nobel laureates who came here. UN had asked him, Mahalnobis, to prepare a sampling structure for the UN and give it to them. And at one point of time, the Indian Statistical Institute was a citadel of learning sampling techniques, because उन्होंने पहली NSSO की जो study थी, वो sampling के ऊपर, जब second plan बनाना था, तो he took the sampling and from there he came up with all the generalizations, and we are doing that. So please read about PC Mahalnobis, Prashanto Chandra Mahalnobis, a great statistician, a great mind that India had. And he changed the Leontief's input-output model. Leontief was a Russian economist, a mathematician basically. He gave an input-output model, that how much should the economy input and how much the output would be. And he gave it for a two-sector model. He just talked about a two-sector model. Mahalnobis expanded it to a four-sector model and gave it, and on that basis, all our 5-year plans were based on that. So, gem of a person, like gem of a brain, okay, which we required. So this is what sampling is. Sampling is basically you're just taking from the entire population, you're taking a few and you're trying to generalize. Now, as I said, otherwise it's time consuming, it's expensive, all those things are there. So, right, thank you. Person knows for whom I'm using that, thank you. Okay, so like here, this is an example that we have taken. The parliament is debating a ban on alcohol in all the places of worship. You are asked to conduct the survey. You go to all the bar owners, as they will be affected the most, and interview them. You then report that 93% of all those interviewed wanted alcohol prohibition rules to be repealed or to be stopped. Now, this is like, again, you conducted a survey. Please remember that you conducted a survey. You did not do a census study. You conducted a survey, because it's not possible, because in India, there are n number of people who are selling alcohol legally or illegally. So you cannot go to all of them and you cannot ask them. So you just visit a few and then you come up with this 93%, that 93% of them want the prohibition rules to be repealed. Of course, the government loses out a lot of revenue. So it's better that people keep drinking. Yeah. Of course, I'm not condoning it, right? So this is the sampling framework. Like, how do you do your this thing? How do you do your sampling? So you have got your like the population is there. Then you frame a sampling framework is there, how do you go, there are various ways of going for sampling framework, and then the sampling process, you draw a sample and then you draw an inference about the population. शायद बहुत जल्दी बता गई. Let me repeat. आपके पास population है, आपने उसमें एक sampling framework draw किया, that how to take a sample from it, because it has to be representative. Like for example, right now you are from you are studying from the Bhopal center, so let's talk about MP. Madhya Pradesh has got how many districts? Anybody has got any clue about MP? How many districts are there? 51, 52. When I left MP, there were 51 districts. Right now, how many districts are there? How many districts do we have? Nobody has got any idea? I think so it's 52, if I'm not 50? Sure. 50 districts. 50 districts are there in Madhya Pradesh. Now, it's not possible to do for all the 50. So what we do is we divide MP into regions. Say we take Malwa, we take Bundelkhand, we take Baghelkhand, we take Narmadapuram, and then we draw the sample. So this is like we have stratified it, and then we take, say, 3 districts from here, 2 districts from here, 2 districts from here, 2 districts from here, and in total we do a sampling of 9 districts. So this is a sampling framework, and then of course sampling framework is not so easy. From the 9 districts, then you find out that how much should be your total sample. Acha, tell me, how do you find out that what should be your total sample? Like, "52 districts." Yes, thank you. गलत information दी. बताओ. मुझे ऐसा याद था कि 52 हो गए हैं. This is what I remembered exactly. 50 with 10 divisions. Okay, Shruti, these are the, of course, 10 divisions are there. I know that. I just took these because Bundelkhand and Baghelkhand नहीं है उन divisions में. उनको अलग तरीके से किया गया है. These are the popular divisions that I'm talking about. Now, what should be the sample size? How to decide on the sample size? How do we do that? Very quickly. How do we decide on the sample size? ज़्यादा सवाल पूछ लेती हूँ क्या? आप में से किसी ने कभी सैम्पलिंग नहीं करी? अच्छा, कुछ मत करिए. गूगल बाबा है हमारे लिए. Okay, there are various formulas. There are various formulas formulas are there to find out the sample size, and you can use any of those formulas with a 95% of confidence level. ये जो 95% confidence level कह रही हूँ ना, ये वही है 2 standard deviation वाला 95%. ठीक है. 99% पे तो हम नहीं बात करते हैं यहाँ पे. जब when we are doing our sampling, so we take 95%. So 95% confidence level, you can go to Google, and there are built-in calculators for you. You just write your population, you give them your population size, and it will estimate a sample for you and give it to you. And even if you do not know the population, many cases the population is not defined. So if the population is not defined, then also it will give you a number that how to go about it. it becomes a bit difficult. It becomes a bit difficult if you do not know your population size. If you know your population size, it becomes very easy. Roughly, the figure nowadays which comes out to be is 396. 396 आपका sample size थोड़ा बहुत ऊपर नीचे 396 के आसपास आता है. Okay, so okay, look, अच्छा ये मैंने कुछ करके रखा हुआ है. So I said sample size is 400. There are 5 zones. Jhabua, we have taken the western zones. So we have got Jhabua, Neemuch, Mandsaur, Ratlam, Ujjain, Indore, Dhar, Khandwa, Khargone here, and then we draw this we have drawn from the 5 zones. We have drawn the population 120, 60. Of course, when you're taking the sample, whenever you are taking the sample, please remember there has to be a weight. When I use the word weight here, that means that's the basis on the basis of taking the sample. So it can be, I can say that the district with highest per capita income, district with highest population, district with highest land holding size. It can vary. It can vary from like it depends on the study that you are conducting. But you have to have a weight, otherwise your sampling framework won't be correct. वो जो आपने sampling किया है वो सही नहीं होगा if it is not that way. So you have to take the weight and you have to talk accordingly, right? Sure. Let me just okay, so here we are talking about if the population is homogeneous. So if our population is homogeneous, then of course if your population is a population is homogeneous means what? Like of the same type. The word homogeneous means of the same type, right? So then it becomes a bit easier. Homogeneous mein. If it is heterogeneous, then you have to have clusters, you have to have stratas for that, so that there is a fair representation. Okay, that the representation that you are giving, the representation has to be fair. So you need to work accordingly. This is how you do it. You population sampling frame, you determine now there's simple random sampling, stratified sampling, cluster sampling, systematic sampling, multi-stage sampling, and then you've got non-probability sampling. What's the difference between probability sampling and probability sampling? Probability sampling and non-probability sampling. What is the difference? Yes. Let's not waste time by asking questions.
Ma'am, in
हाँ
case
जी.
of probability sampling,
Hmm.
all the observations have equal chances of getting picked up for sampling.
Great, Ganesh. Absolutely right answer. Absolutely right answer. That here each member of the population has equal chance of getting selected in the sample. And here, not equal chance. This is more of like we have used the word convenient, judgmental, quota, snowball sampling. So this is like a very convenient thing when many a times, like for example, like I'm a teacher and I want to find out how many drug users are there in my like the students that I'm teaching. Do you think probability sampling will work there? If I want to find out the drug users, will probability sampling work? Yes or no? Yes or no? No, absolutely right. No, because nobody is going to come out and say, "Ki, हाँ, हाँ, मैं drug user हूँ." Obviously not. Then what you do? You do snowball sampling. If you say, supposingly, I know of one of the students who is using drugs, I can then ask that person that, okay, who are your fellow students who are doing it? And we, of course, there will be different method of finding it out, because you have to cajole out that information. They won't be giving it very easily to you. So if there are so many things when your issues are very sensitive, there are certain things which people are not ready to come out with. Say somebody who has been sexually assaulted, people won't come because of the societal pressures. People won't come out with it. Of course, it's very wrong. People who have been assaulted should come out. The people who have assaulted should be hiding. But of course, in India, it's a reverse that it works. So there are so many things. So there we use non-probability sampling. Otherwise, we go in for probability sampling, right? So we'll do one thing. We'll stop our class here, and for today. And Dr. Gargav, we are stopping our class here, and we'll continue on Sunday. Please read a bit more about sampling and stuff, and come to the class. We'll then move to correlation regression, right? I don't know whether she's here or not. Like.
So it's over. Today's meeting is over.
Yeah, today I have covered a lot of things. It's already 2 hours. So
Okay.
on Saturday we don't have a session.
No, so yes, Saturday we are not having any session.
Right.
And Sunday we are having. I just wanted to, if you and learners are ready, if you want, we can arrange Saturday's session on coming Sunday. If you want and learners want.
The next Sunday, that means?
No, this Sunday. Like tomorrow we are not having any session. That is why. If you are okay, and if learners are okay, we can think for Sunday session. Yeah, that would be too much. Like in between you can have a break of. Then it's okay. We'll have it on next Sunday. Okay. I know it's not possible.
It's very too big a session, too longer session. ये भी पक जाएंगे, मैं भी पक जाऊंगी. So let's have two sessions.
But I think we'll have next session on Sunday. And after that we will have one more class for this MMPC 005. Might be on coming Sunday.
Yes, that we can do.
Okay, I'll talk to you, and then I'll inform the learners accordingly.
Sure. Thank you. Thank you so much.
Thank you, Tanima ji.
Thank you.
And learners, I hope you enjoyed today's learning. I can see a lot of messages in the message chat box. If anybody want to say anything or thank our academic counselor.
They have thanked me here. They have thanked me on the chat box. So I suppose it's okay.
Thank you so much, ma'am. It was a wonderful session, ma'am. Thank you so much.
Thank you. Bless you. Thank you. Bless you.
Thank you so much, ma'am. It was very informative.
Right. Bless you.
Thank you.
Yep. And right.
So we are still not having any electricity at home. So
It's okay.
okay,
Okay.
it's like
Fine.
that only.
So
Thank you, Tanima. Thank you, everyone.
okay.
I have
I'm
recorded this session and I'll upload it on the YouTube channel later on.
I'm leaving the session then, Dr. Kargav. I'm leaving it.
Okay, okay.
Okay. Thank you.
Okay.
Thank you. Good night.
Thank you. Okay, good night. Good night, everyone.
Good night, ma'am.